All right, guys. So what we're doing today is we're finishing up the note sheet from yesterday. Now, the first problem I want to start off with is this one here. Now, we did do this problem yesterday, and I want to go over another way to look at it, another way to solve it. All right. All right, so we're going to look at another way to simplify this, another way to solve this here, rewriting this expression in simplest form. Now, we worked on a way to do this yesterday with using fractional exponents. This way, we won't be using fractional exponents, but we will still get to the same answer, the same result. So the first thing we look at and see is if we can take the fifth root of 4. Well, no. We couldn't take the fifth root of 4 yesterday. We still cannot take the fifth root of 4 today and get a nice number. Now, the next one we go to is a to the 8th. Now, what we did with the fractional exponents is we're taking out groups of 5. Because if we have a to the 5/5, it simplifies out and the radical reduces. So another way to look at this is seeing how many groups of 5 a's can we remove from a to the 8th. And we could write it out, because we can say 8 minus 5 is 3, which tells me I can remove one group of 5 a's from inside the radical. Can we subtract 5 again from 3? I mean, we can, but we get a negative number. So what that tells us is that we can take one group of 5 a's out, and the remainder is how many are left inside. So we would have a to the 3rd left inside. Questions on this here? Now we can look at b to the 14th next and see how many groups of 5 we can remove from it. So we can do 14 minus 5, which is 9. Then we can do 9 minus 5, which is 4. But we can't take 5 away from it again. So that tells us that we can take 2 groups of 5 out of the radical, giving us b squared. And then we have how many left inside? 4. So we have b to the 4th. And the last one we have is c to the 5th. We can do 5 minus 5, which is 0. So we can take one group of 5c's out, which would just be c to the 1st. And we have how many left inside the radical? 4. So that's the answer. So that's the exact same process that we did yesterday, but in a more simplified version. Questions on any of this here? Let's look at this again, because I think it'd be good to see this at least one more time, seeing how this works. And I have a feeling y'all like using this method more than the fractional exponent version. So when we look at this here, the cubed root of 2, we can't simplify. 2 is a prime number. There's no way to reduce it from there. Now the next term we can look at is a to the 13th. So we're trying to see how many groups of 3 we can take out of 13, which would be. So we can say 13 minus 3 is 10. 10 minus 3 is 7. 7 minus 3 is 4. 4 minus 3 is 1. So we keep taking those groups of 3 out until we can't anymore. And we're able to do it a total of 4 times. So we have a to the 4th on the outside. How many a's are left inside? A to the 1st, a to the 1. We don't have to write it because it's understood. We can look at b next. So groups of 3 away from 3, well, 3 minus 3 is 0. So we can take one group of 3 b's away from b to the third, and we have none left inside. And lastly, we have c to the 8th. So we can say 8 minus 3 is 5. 5 minus 3 is 2. So 2 minus 3 would give us a negative number, so we can't go on from there. Nice. Which means we can take how many out? 2. And we have how many left? 2. And that's it. Any questions on any of this here? Now, we'll look at this one here next, again in a non-fractional exponent form. And then we'll do the other one of this type. Or did we get to this one yesterday? I think we might have stopped here. So when we look at this one here, we could rewrite the cubed root of y to the 8th in fractional form. Y to the 8 thirds is what we want, and what we want to do with this here is simplify the radical out of the bottom of the fraction. We cannot have a radical, this cubed root in the bottom of the fraction. But, okay. But we can't just simplify as it is, because I can't take an even group of 3 away from 8. Because if we tried this here, 8 minus 3 is 5. So 8 minus 3 is 5. 5 minus 3 is 2. We can't take another group of 3 away from it. So we need to multiply the top and bottom of this by the cubed root of y to some power. We need cubed roots because the only way we can multiply the denominator and get this cubed root to simplify is by a cubed root. And we need to see how many y's we need to multiply it by. Now, since the exponent is 8, we want to see what exponent or what number after 8 will divide by 3 evenly. What's the next number after 8 that divides by 3 evenly? 9. How many y's are we short from having y to the 9th? 1, because we are only 1 away from 9, yes? So we're going to multiply the top and bottom of this by the cubed root of y, because we just need one more. The numerator, we'll multiply them together. X times the cubed root of y. The denominator, it's still going to be the cubed root, because when we multiply 2 cubed roots together, we still have the cubed root. We multiply what's inside. Y to the 8th times y is going to be y to the 9th. Now, the last thing we need to do is simplify the cubed root of y to the 9th. Well, how many groups of 3 can we take away from y to the 9th? 3. So it leaves us with y to the, and that's it. So we're just increasing the degree of the denominator to a point that we can actually take the cubed root of it. And we do the same and apply that to the top as well. Questions on this here? Okay. We're going to jump to the other one of that type. I really do need to reorder these notes so that they're together and not separated. Now looking at this one here, since we do have the cubed root of y to the 13 on bottom, we're going to have to multiply top and bottom by y, the cubed root of y, to some power. Now, we can't take the cubed root of 13. 13 is not divisible by 3. But we need to find the next number after 13 that is. What is the next number after 13 that's divisible by 3? 15. How far are we away from it? So multiply top and bottom by y squared. So it would simplify out, but we're multiplying on top and bottom to get that denominator's rational or radical to simplify. Now, one thing I will say is that whatever we multiply the top and bottom of this by inside that radical, the exponent will never be bigger than the index. The exponent should never be bigger than the index. Because if we go beyond the index, that variable inside there can come out. So the indexes are 3, the root. Because if we multiplied it by the cubed root of y cubed, well, the cubed root of y cubed is just y. So anything above that is extra we don't need. Now in the denominator, we are going to have the cubed root of y to the 15th, which is what we wanted. The numerator is going to be x squared times the cubed root of y squared. Because we can't multiply the x squared and y squared, since the x squared does not have a cubed root, it just stays out front. And we'll have that in our final answer. Now the cubed root of y to the 15th, how many groups of 3 can we take away from 15? Or 15 divided by 3 is? Yes, because the cubed root of y to the 15th as a rational exponent would be y to the 15th over 3, which is indeed y to the 5th. 45. Any questions on this here? Okay. We're going to do one last set of jumps, and then the rest of this will actually flow the way the note sheet's set up. Looking at this here, if we want to simplify this, the first thing we need to do is divide. 14 divided by 2 is 7. 14 divided by 2 is 7. So we're going to use our properties of division and dividing to simplify this. Now the next thing we have is, guys, dividing like bases. We have x to the first on top, x to the 3/4 on bottom. Whenever we divide like bases, we subtract the exponents. So for x, we're going to have 1 minus 3/4. When we divide like bases, we subtract the exponents. Now y is our next variable, but there's only one y. There's only y's on top. There's none in the denominator. So we just have it as y to the 1/3. So that's taking care of everything except for z to the -6 in the denominator. Now to make that variable or the exponent positive, we can move it from the denominator to the numerator. If it was in the numerator, we can move it to the denominator to make it positive. Whenever we move a term from the top to the bottom or bottom to the top, the exponent goes from positive to negative or negative to positive. Now the last thing we need to do, guys, is 1 minus 3/4. 1 minus 3/4 is? It's 1/4. And that's it. That's all we have to do for this year. Any questions on any of this here? Okay. We're going to make the last jump in the notes to this here, and then the rest is going to actually follow from here. We're not going to have to skip around anymore. Now again, on this one here, we're going to divide, essentially moving everything to the numerator and then taking care of it from there. So the first thing we can do is 16 divided by 8 is 2. For our x's, we have, guys, let's focus up here. We have x to the first on top. We have x to the 2/3 on bottom. So whenever we divide like bases, we can subtract the exponents. So we're going to say 1 minus 2/3. Now y is only in the numerator, so we can leave it as y to the 1/3. And lastly, z to the -4, guys. To make the exponent positive, because we do need all the exponents to be positive, we can move it from the denominator to the numerator, taking it from z to the -4th to just z to the 4th. And last but not least, we need to subtract our exponents, so 1 minus 2/3 is 1/3. So we get the expression 2x to the 1/3, y to the 1/3, z to the 4th. Any questions on any of this here? We ready for the next piece? Perform each indicated operation, assume all variables are positive. And again, this here is essentially what we started yesterday with. This here is actually the same thing as what we started yesterday with, except what's inside the radical is not a number. Because what we started yesterday with was the square root or the cubed root of 12 and had a number. But as long as the radical, these terms here, are the exact same, we can add or subtract the numbers in front of them. So here, 5 square roots of y plus 6 square roots of y. Well, 5 plus 6 is square roots of. That's it. That's all I have to do. Now that brings the question for the next one. They're not the same. Because here we have just the cubed root of 2z to the 5th. This one here we have z cubed roots of 54z squared. We need to get them to be the same by simplifying them. So the first thing, looking at this here, the cubed root of 2z to the 5th. Well, we can't take the cubed root of 2. 2 is as simple as it gets, so we'll have that there. Now, z to the 5th, that can simplify. Because with variables, if the exponent's bigger than the root, bigger than the index, it can be reduced. How many z's can we take, groups of 3 z's can we take away from z to the 5th? 1. How many are left inside? 2. If we take 3 away from 5, we're left with 2, yes? Minus. Well, now do the z squares match up inside the radical between the two? Well, the first one has z squared, the second one has z squared. So we now have z squared and z squared, yes? We do have a z out front, so those match, yes? So if we're going to actually be able to subtract it, we do have the z, cubed root of z squared. What do I need the 54 to reduce to inside the radical? We need it to reduce to a 2, yes? Because if it reduces to a 2, these two terms are now the same. Because the only way we can add or subtract is if they are the same. Exactly. So it does give us an idea of what one of the factors we need to look at with 57 is, and it is 2. And what times 2 is 54? 27. Yeah, and we could go from here and say 27 is 3 and 9, 9 is 3 and 3. Or we can look at, say, the cubed root of 27, the calculator is 3, yes? So that means, guys, for this here, we would be able to bring a 3 out of the radical. Because the cubed root of 27 is our 3. So in yesterday, when we looked at some of these here, we rewrote it as the cubed root of 3 cubed times 2 times z squared. But we can just bring it out. Questions on this so far? Guys? So now we just need to subtract our two terms. So 12 minus 3 is 9. Z cubed root of 2z squared. And that's it. Any questions on this here? 6 cubed roots of x plus 2 cubed roots of x is what? Because since the radicals in our terms are already the same, we can just add the numbers together. Or if we were subtracting, we would subtract them. Any questions on this here? Let's look at this next one. So we need to simplify each term so that our expressions have the same variables and radicals. Now we can't take the fourth root of 3. Now the fourth root of p to the 6th, since the variable 6 is bigger than our index of 4, we can bring a certain number of them out. How many can we bring out? 1, because we can only take one group of 4 away from 6. And that leaves how many inside? 2. Now, the p's do match up inside. We have p squared and p squared, yes? Outside the radical, we do have p and p. So that's good there. Now, the 48 does not match up with our 3. So we need to simplify the cubed root of 48 if we can, or the fourth root of 48. And that's going to be 3 times 16. So now we need to determine what the fourth root of 16 is. And the fourth root of 16 is 2. So we'd have 3 inside and 2 outside. So now we just need to subtract. 16 minus 2 is p. Fourth root of 3p squared. Once we get them to be the same, they're pretty easy, or pretty nice. But it's just getting them to be the same. That takes a step. Now, luckily, for the most part, the problems that we have do give us a lot of hints at it. Because most of the ones that we will have, one of the two numbers is already going to be in simplest form. And in between the two of them, one of the two variables will be in simplest form. And we can work from there. All right, guys, stay focused up here. Any questions on any of this here? Guys. So, again, guys, we're going to go back over these here because this is essentially some of the stuff we went over. The first one, the cubed root of 27 q to the 9th. We can look at the cubed root of 27 in the calculator, which is 3. Because if we can plug it in and it gives us a nice number, that's the answer. If it doesn't, that means we have to do the factor tree. We have to look at other methods of simplifying it down. Cubed root of q to the 9th. Can we divide 9 by 3 evenly? 3. Or we can take 3 groups of q's out of q to the 9th, leaving us with 3 q to the 3rd. And that's it. Now, the next one, with this division, we could do exactly what we did yesterday. We can split it up as the 5th root of x to the 10th on top, the 5th root of y to the 5th on bottom. Or we can look at this and say, how many groups of 5, exactly, can we take out of x to the 10th? We can take 5 out twice, which gives us x squared. In the denominator, how many groups of 5 y's can we take out? 1. Which we can write it as y to the 1st or just y. So the 5th root of x to the 10th divided by y to the 5th is x squared over y. We did this one here today. We can divide these. So we can start off by 6 divided by 3 is 2. Whenever we have like bases, we subtract the exponents. the numerator's exponent is 1. The denominator's is 1/2. So we'd have 1 minus 1/2. This one here, unlike the others, we do have y in the numerator and denominator. So we'd have y to the 3/4 minus 1/2. Now the last thing we need to do is simplify this. So we're going to do 1 minus 1/2. And 1 minus 1/2 is 1/2. 3/4 minus 1/2 is 1/4. And we could do that in a calculator. We could say 3/4 minus 1/2 is 1/4. And that there's the final answer. And lastly, guys, the square root of 9w to the 5th minus w squared of w cubed. Well, looking at this here, we could take the square root of 9. We've done that before. It's not too bad. The square root of 9 is 3. Now we do need to simplify the square root of w to the 5th. How many groups can we take out? Because how many times can we subtract 2 from 5? Twice, which leaves us with the square root of w. And it was very they were leading us with having to be w to the 1st. But if we look at the other one here, inside we have w cubed. We can simplify that. We can take another w out of the square root, which gives us w squared, square root of w. Now we do have both terms the exact same, so we can do 3 minus 1, which is 2, w squared, square root of w. Any questions on any of this here? Any questions on anything we've done so far? Now the homework it's on there. I created it as a worksheet, but if you notice, the assignment numbers or the problem numbers on the worksheet do match this here. So if you do lose that sheet in the textbook, the digital textbook, which is in Google Classroom, on page 252, it is problems 37 through 44, 49 through 52, 57, and 59. I have also included this worksheet in Google Classroom, so there's another place that you can find it and utilize it. I can get some here in a minute. Also, tomorrow we have a quiz over 5.1 and 5.2. So what we've done in 5.1 and 5.2. Okay? So just as a heads up, if you want to look back over those, you can. Is that what we did last week? So simplifying the radicals, there will be 2 with solving. The steps where we did with solving, or we're just getting either the parentheses by itself and then taking the nth root, whatever the power is of both sides, or getting the variable by itself and then taking that root of both sides. And remember, if we take an even root, we need the plus or minus. Estimating or approximating the radical as a decimal, plugging it in and solving, and doing what we did today.